Hi, everybody. Okay, so yesterday we did population, standard deviation, and variance using the football example. And today we're going to do sample, standard deviation, and variance. This is actually very similar to population, standard deviation, and variance, just one change, which is good because it'll give you a chance to actually try a different problem. So let's say that we have 4 numbers. Okay, and this is a sample, not a population. So before, like when it was a population, it's every single thing. For example, when we were doing the football games, it was every single game we played. But this, in the preseason, but this right here is a sample of a larger data set, we're assuming. And so we're going to start finding the standard deviation like normal. So do the steps with me. Okay, actually it's this one I think we add up. Make sure you have your paper set up like I have it set up. Okay, so first we're going to have to find the average, and to find a sample average is just the same as finding a population, okay, but a sample mean actually looks like this, and it's called X bar. And there's no difference in how you find a mean, a population mean, which is mu. So mu is a population mean, and X bar is a sample mean, but really they're the exact same thing, same way to figure it out. Just the different letter notates that we're talking about a sample or a population. And again, this is called X bar for real, for realsies. So I'm going to add up 1 and 3 and 5 and 7, and then divide by 4. Which is 4. So my X bar for this is 4. So really, I shouldn't have these labels up here because I'm not going to subtract mu after all. I'm going to subtract X bar. Okay, so 1 minus 4 is -3, and 3 minus 4 is -1, and 5 minus 4 is 1, and 7 minus 4 is +3. And then I'm going to square each one of those. So here's the x minus x bar over here, and then I'm going to square each one of those. So this makes 9, because -3 squared is 9. -1 squared is 1, 1 squared is 1, and 3 squared is 9. And if I add those all up, I get 20. So if I do the summation, I get 20. All right, now, so far, everything is exactly the same as finding a population standard deviation. Now what we're going to do is instead of dividing by 4, we're actually going to divide by n minus 1. So we're going to divide by 3. I'm actually going to write out the whole equation for sample standard deviation here. So sample standard deviation is denoted by an S, not by that sigma. And again, the only difference is that it's a sample, not a population. And the equation for this is taking the summation of all of the deviations squared, and then you're going to divide by n minus 1 instead of n, and then take the square root of it at the end. So really, the only difference between finding a population standard deviation and a sample standard deviation is just that n minus 1. You're dividing by 1 less. So on this one, you see how we had 4 data points. So normally I'd divide by 4 here, but instead what we're going to do is we're going to divide by 3. And the reason is because it's assuming that, so if I divided by 4, I would have gotten 5, but if I take 20 divided by 3, I get 6 2/3. So basically, it's accounting for the fact that there are probably not outliers in this data. So if I only look at 4 numbers out of who knows how many, maybe there were like 25 numbers or 800 numbers or whatever, and I only look at 4 of them, the chances that I have the outlier in the set that I'm looking at is very unlikely. So they reduce this by 1 to make your standard deviation a little bit larger. So you get about 6.6 repeating here, and then you take a square root of both of those. Which gives me about 2.6-ish for my standard deviation. Now, this number, before I took a square root, that's 6.6 repeating, that was the variance. So the step right before you take the square root is the variance. I'm going to write variance next to this one, and standard deviation next to this one. So just as a once more looking at it, basically it is exactly the same problem as the one we did yesterday if you're doing a sample standard deviation, except for sample mean is called x bar, but it's still the same process. Sample standard deviation is called S. It's almost the same process, except for instead you divide by n minus 1 instead of n. And I'm telling you right now, if you're watching this video and you're paying attention, that I'm going to put this question on the test. I'm going to say, why do you divide by n minus 1 instead of n? And the answer is because it's really unlikely that in our sample data set we have an outlier in there, because outliers are few and far between. And so it's super unlikely that we would have a outlier involved at all. And since we're going to assume that the outlier isn't there, then we reduce it by 1, which makes your standard deviation a little wider to account for adding in the outlier. So we needed just a little bit more from that. Okay. Your homework is going to be, let's do 2 problems. This is page 93. And let's do number 13, which is a population standard deviation. So that's like yesterday. And we're going to do '15, which is sample standard deviation. Okay, and that's due tomorrow. 2 problems due tomorrow. They'll take a little bit, but you can get them done. All right, come back into the Teams chat if you have any questions for me. Thanks, bye.